Students, see our next topic, instrumentation of IR spectroscopy. Okay, we already know principle of IR spectroscopy. Okay, next one is instrumentation of IR spectroscopy. This is the block diagram of instrumentation of IR spectroscopy. In this one, radiation source. The first component is radiation source. Okay, these two are the mirrors. These two also mirrors. Okay, next one, radiation source releases IR rays. Both sides is there. Okay, from top direction we take a reference material. In bottom direction we take a sample material. Okay, reference material releases reflection ray and also sample material also releases reflection ray. Okay, these two are moves towards chopper. Chopper produce radiation IR radiation. These IR radiation bulk range of IR radiation moves towards monochromator. Monochromator separates bulk radiation into mono radiation. Monochromator purposes, it's a bulk rays is converted into single ray. This single ray is moves towards detector chamber. Detector detects the signals. These signals are moves towards amplifier chamber. Amplifier chamber amplifies the signal, and then this signal is displayed in recorder component. These are the components used in instrumentation of IR spectroscopy. See one by one. Our first component is radiation source. Okay, radiation source purpose is which gives IR radiation. Okay, we use two types of radiation sources. First one is Nernst Glover. Okay, the first radiation source is Nernst Glover. Nernst Glover means which is the oxides of zirconium, yttrium and erbium oxide, erbium metal oxides material. Nernst Glover is prepared with combination of oxides of zirconium metal, yttrium metal and erbium metal. Next one, second source is Glober. Glober is nothing but it's a rod of sintered silicon carbide material. Sintered silicon carbide material, which is a mixed material of silicon and carbide material. It's a rod. Okay, right? That is the Glober. These two are radiation sources used in instrumentation of IR spectroscopy. Okay, next one, see second one. Okay, second material is sampling. Okay, sampling technique, that is sample material, sample chamber. Our sample chamber is prepared with quartz material. We already know in UV visible spectroscopy. In IR spectroscopy, the sampling techniques are four techniques. Okay, solid sampling, liquid sampling, gas sampling, solution sampling. Okay, these four are sampling techniques involved in IR spectroscopy. Next one is third material is monochromator. Monochromator materials are, first one is prisms. Prisms is nothing but these are the alkali metal halides material. Prisms are alkali metal halides materials like sodium chloride, potassium bromide, next one lithium fluoride, cerium bromide. Cerium bromide. These are the prism materials. Okay, next one, grating. Grating is nothing but a set of equally spaced parallel wires used to produce spectrum by diffraction. Diffraction means bending manner. A set of equally spaced parallel wires used to produce spectra by diffraction phenomena. This is the grating material. These two materials are used as a monochromators in IR spectroscopy. Next one, see detectors. Okay, detectors materials. Detectors are different detectors are used in IR spectroscopy. This is the first one. Bolometer is the first one. Bolometer is nothing but thin metal conductor. Okay, thin metal conductor. Bolometer is a thin metal, thin state of metal conductor. Okay, we already know metal character is conductor character, but bolometer is a thin. Okay, it's a thin one, very thin one, very thin metal conductor material. Okay, by using bolometer as a detector, increasing temperature and increasing resistance. Temperature is increases, resistance also increases. Here the current flow is changes. Current flow is changes. That is the identification of detector. Okay, that is the bolometer. Bolometer means it's a thin metal conductor, increasing of temperature and increasing the resistance. Here current flow changes, detect the signal. Okay, that is the bolometer part. Next one is thermocouple. Thermocouple means here the temperature difference. Okay, the temperature is a different temperature. So potential also difference. Temperature is differences, so potential also difference. Okay, suppose see, it is a thermocouple material. Thermocouple material means two different metals. Whenever I top side one more metal wire, here this is the different metal wires. Okay, IR rays is entering into in this side acts as a hot junction, and then this side acts as a cold junction. Okay, that is the temperature difference, so potential difference is there. That is the thermocouple material. Okay, next one see thermistor material. Thermistor, it is the third detector material. Thermistor means fused metal oxide mixture. Suppose fused metal oxides. Suppose sodium metal. Sodium is the fused metal. Okay, sodium oxide mixture. Sodium oxide acts as a thermistor material. Thermistor case is increasing of temperature, decreasing resistance. Okay, thermistor identification is increasing of temperature changes into decreasing of resistance. That is the thermistor character. Next one see Gole detector. Gole detector is nothing but xenon is filled in a cylinder. Xenon gas. Okay, xenon gas is the inert gas. Inert gas is filled in a cylinder which acts as a Gole detector material. Next one is photoconductivity detector. Photoconductivity detector means lead sulfide present. Okay, photoconductivity detector have lead sulfide material. Okay, next one, last detector material is semiconductor detector. Semiconductor detector means conductance is increases. Generally, semiconductor have partial conductance value. But in this case, semiconductor detector conductance is increases. Okay, that means semiconductor is changes into conductor character, which is used to identify, detect the signals. These are the detectors materials we already know in UV spectroscopy, amplifier and recorder purpose. These are the instrumentation of IR spectroscopy. Is it clear, student? Thank you.